Hey folks, welcome to the NZQA Level 2 Algebra paper from 2023. If you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieved merit excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, unpause the video, and then see how I go about answering the question. So, without further ado, let's get started. All right, so for question one, what we need to do is we need to simplify each of these expressions. So the first thing we want to do is I'm going to get rid of this brackets here. So when I actually get rid of that bracket, what I'm going to end up with is 4 multiplied by 2 to the power of 3 and then n to the power of 3. So 2 to the power of 3 is going to be 8 and then multiplied by n to the power of 3. And all of that is divided by n to the power of 8. So the next thing is I've got 4 times 8, that's going to be 32. So I'm going to have the fifth root of 32 and then n cubed divided by n to the power of 8. Now there's n cubed in the numerator, n8 in the denominator, so it means I can cancel that out and I leave that with n5 in the denominator. So what I've got is the fifth root of 32 over n to the power of 5. Now at this point, I can get rid of the square roots, well, the fifth root symbol by simply putting it as a power of a fraction. So I'm going to get 32 to the power of n to the power of 5 to the power of 1/5. And then what I've got is I've got 32 to the power of 1/5 divided by n to the power of 5 times 1/5. Now 32 to the power of 1/5, now that's going to be 2. But I'm just going to show you folks how to do that in the calculator. Really important that you put the 1/5 in a bracket. So we're going to put 1/5 in a bracket. Otherwise, you're going to end up with some ugly numbers there. So what we've got here is we've actually got 2 to the power of 5 times 1/5 is just 1. So that's going to be 2 over n. Grades wise, this question is actually worth and achieved. So let's see, correctly simplify positive index. Yep. So that is actually worth and achieved. Moving on to question A, part 2. So part 2, there's a couple of ways you could do this, right? I mean, like you could actually get rid of the n first and then you could deal with the negative power, whichever one is comfortable for you. So the one I'm going to do is I'm going to get rid of the negative 0.5 first, which means if I want to get rid of a power that's negative, all I've got to do is flip the whole fraction upside down and then put it as positive 0.5. So remember that when you want to change the negative power to a positive, all you got to do is just flip the fraction. All right, so what we got is we've got n6 and n cubed, which means we can cancel out n cubed and write this as n3, and what we're going to end up with is we've got 16n to the power of 3, and that is now to the power of 0.5. Now remember, 16 does have a power. It has 16 to the power of 1. Sometimes people forget that. So we've got 16 to the power of 1 times 0.5, and then n to the power of 3 times 0.5. So with that in mind, we've got 1 times 0.5 is just 16 to the power of 0.5, and then 3 times 0.5 can be just written as 1.5, or in this case, I'm just going to put that as 3 over 2. Now 16 to the power of 0.5, that's just square root of 16, which is 4. So I mean, if you're in doubt, you can always put that in the calculator. So we're going to end up with an answer of 4n to the power of 3 over 2. You could write as 1.5, it's not a big deal. Basically, at this point, you actually get an achieved for this grade, for this question. Looking at the answer schedule, there is a couple of unsimplified equivalent fraction. Oh yeah, no, that's fine. No, we can actually leave it as this for now for achieved. All right, so next question. Right, so the next question, what we want is we've got to actually factorize this equation here, right? Like, now I'm going to be honest with you folks, like anytime I see these questions, what I do is I kind of cheat. I'm going to be honest, I cheat. And the way I cheat is this: I look at the denominator and I go, well, usually with these questions, there's always a common factor in the denominator and there's a common factor in the numerator. But before getting to that, let's actually do the denominator first. So in the denominator, I am going to get, I can see that x is a common factor, so I'm going to take out x as a common factor, which means I'm going to end up with 5x minus 3. Now let's think about this logically, all right? With these kind of fractions questions, there's always a common factor. Now, particularly looking at this question, there is no way I'm going to have x as a common factor, right? I'm going to have 5x minus 3 as one of those factors. But let's say, hypothetically, you don't want to use the shortcut and you want to actually learn how to do this properly. Then what we need to do is we need to factorize the numerator. So what I'm going to do is I'm going to take out the common factor of 2. By the way, just keep in mind, I'm going to do my shortcut. Well, I'm going to put my shortcut method here. And I'll show you how this works as well. So I'm going to leave that aside for now. So for now, here in the numerator, I've got 2 as a common factor. So I can write this as 10x squared minus 11x plus 3. So what I need to do is I actually need to factorize the numerator there, where it's 10x squared minus 11x plus 3. Now, if you've been actually following some of my little cheat tutorials that I do, what you can do is you can actually use your graphics calculator to factorize this. It's a bit of a cheat way to do it, but it still works. So what you need to do is go into equation, click on the polynomial, degree 2, and then what we're going to do is we're going to put this 10, negative 11, and 3. All right, so here's how the little trick works, right? Now we've got two answers here, as you can see, 3 over 5 and 1 over 2. So think about it like this. I kind of do this like I write the solutions down. So if you think about it, one of the solutions is x equals to 3 over 5. And if I go backwards, I would get 5x is equal to 3. And then I could say 5x minus 3 equals to 0. So I'm using the solution to find the factor. So if you think about the other one, we've got x equals to half. So when x equals to a half, we can say that 2x is equal to 1. And then 2x minus 1 is equal to 0. So basically what I've done is I've actually figured out both of my factors. So I can write it like this. 2, what have we got? 5x minus 3, 2x minus 1, divided by x times 5x minus 3. Now at this point, I can kind of see that there's two common factors. I can actually cancel those two things out. And what I'm left with is just 2x minus 1 divided by x. But unfortunately, this is not in the format of a plus b over x. So I still got to do a little bit of work extra here. I'm going to try and fit the answers in here, but what I'm going to do is I'm going to expand the brackets. So when I say expanding, I'm doing this, expanding the brackets, and what I'm going to get is 2 times 2x, which is 4x, minus 2 over x. Now, x is a common denominator, so I'm going to separate the denominators. So I'm going to write 4x over x minus 2 over x. Now what I can do is I can cancel out my two x's. And from here, I can see that a is equal to 4 and b is equal to minus 2. Because now I've actually written it in the format of a plus bx. Sorry, I should have put this like this, 4 minus 2 over x. So grades wise, correct values for a and b, if not, line 3 is required. So basically you need to actually get these two values to get a merit. Correct factorization of numerator is getting an achieved. So getting to this part here is going to get an achieved. Now, I haven't forgotten about the cheat method, the cheat method as we call it, right? So remember, we know the denominator is x and 5x minus 3. Now, that basically means one of the numerators has to be 5x minus 3. Because think about it, they've got to cancel out each other, right? So now what I'm going to do is I'm going to match the coefficients of x squared. So if you think about it like this, whatever this value here in front of x is, I'm just going to put this like this, right? Whatever that the value, the coefficient of x is, multiplied by 5 should equal to 20. Okay, so that means this here is going to be 4. And then finally, if you look at the final values, -3 multiplied by whatever's in that blue kind of thing that I've highlighted there should equal to +6. And so that means this value has to be -2. Okay, I hope you can see the connection between there. So the green coefficients of x will multiply to x squared in the 20x squared. And then the -3 and -2, that's highlighted in blue, it gets multiplied to +6. So now what we can do is we can literally just cancel out these two things. And what we're going to be left over with is just 4x minus 2 over x. And then, of course, I can separate this as 4x over x minus 2 over x. Cancel the two x's, and voila, 4 minus 2x. You might be sitting there going, hey, hang on, can I do this method? Absolutely, you can do this method. But, you know, the shortcut, it works. So I don't see why not. And also with the calculator, when you factorize, sometimes you got to be mindful of the coefficient, right? So because that 4x minus 2 has got a 2 coefficient. So what do I mean by that? Let's say instead of 10, -11, and 3, we actually put down 20. So if we put down 20, -22, and 6, what happens is you still get the same answers as when it was factorized. So it's just something you got to be aware of. So that's why I always say the more practice you do with these questions, you can kind of start figuring out your own shortcuts. All right, so let's go to the next question. The infamous K question. God, I remember the number of the students actually that messaged on the day this exam came out, and they were like, what is this K? So anyway, we're going to actually go through this question, and yeah, hopefully it settles some of those K questions. Okay, so with this question, what's happening is that the only thing that's really new is this E value here. But apart from that, you know, it's a fairly straightforward question, but we'll actually go through it. So what we've got here is the value of this laptop that's been given this, you know, this 40 plus KE 5T, whatever. T, original price of the laptop is 900. How long does it take for the laptop to be reduced to 50%? So the first thing we know is when T is equal to 0, the value of the laptop is equal to 900. So this is the first thing that we know. So what we're going to do then is we've got V is equal to 40 plus KE negative 0.5 T, and we're actually going to substitute T is equal to 0 here and V is equal to 900 here. When we do this, we're going to get 900 is equal to 40 plus KE negative 0.5 times 0. Next line, 900 is equal to 40 plus KE. Negative 0.5 times 0 is actually 0. And I think this is where people started to get kind of going, oh, hang on, I've never seen this E thing. Now I can't actually zoom my calculator there, but right there, if you look in your calculator, just above the ln, shift ln, you would actually see EX. So what we're going to do is we're going to go into the main menu, and we're going to go click shift e to the power of x. So right now we want e to the power of 0. And remember that anytime you have a number, and that's actually raised to the power of 0, you're going to get 1. So then what we're going to get here is 900 equals 40 plus k times 1, because e to the power of 0 is equal to 1. So really we've got 900 equals 40 plus k. So k is equal to 900 minus 40, which means k is equal to 860. Now this is the first part of this question. Now second part of the question is, I mean, it's connected, right? I mean, like we want to try and find when it's going to be 50% of the original value. So if the value was 900, then 50% is 450. So we are going to put in 450 equals 40 plus k, which we figured out that it was 860, e to the power of negative 0.5 t. And right now we're trying to figure out what is t when v is equal to 450, because that's half the value. Now from here you can kind of do this in a couple of ways, right? So first off, you could actually just throw this in the solver and you can actually do it straight away. So for example, you could just go into equation, let's go into solver, and we're going to go 450 equals 40 plus 860. You know, sometimes it works and sometimes it doesn't. Negative 0.5 multiplied by t. You know what, I'm actually going to use alpha t here. RST, there it is. And I'm going to click on solve. So basically this has actually solved the question for me, and the t is equal to 1.48. Now if you want to actually prove this, how it's 1.48, you do need the formula sheet here. And lo and behold, folks, it's actually somewhere here, so you can actually see this. If y equals to e of x, then x equals to ley or ln of y. So this is just a little tip that, you know, it is there in the formula sheet for you to go have a look at. But in saying that, I mean, like, you know, we're just going to work through it fairly quickly. So we're going to rearrange this. We've got 450, and we're going to take away 40 first, which equals to 860 e to the power of negative 0.5 t. So 450 take away 40, that's going to be 410. So we've got 410 is equal to 860 e to the power of negative 0.5 t. Then we've got 410 divided by 860 is equal to e to the power of negative 0.5 t. Now here comes the ln part, right? So you're basically just taking logs on both sides, but instead of logs, you would actually have to use ln, and that's the only difference for this question. So we're going to go ln of 410 over 860 is equal to negative 0.5 t. So then we're going to get t is equal to ln of 410 divided by 860, and the whole thing divided by negative 0.5. So when we do this in the calculator, what are we going to get? If I can find my calculator, there it is. What is it? We were supposed to get an answer of 1.48, but let's have a look. So we're going to do ln of 410 divided by 860. And that's equal to that divided by negative 0.5. And as you can see, that's going to give us an answer of 1.48 years. So grades wise, correctly solved is going to get you an excellence grade. A merit k correctly found using t equals to 0. So merit is going to be here at finding 860. Wow, the t substitute equals to 0 is just achieved. So that's just here. This line right here is going to get you an achieved. Yeah, interesting question. I know it kind of drove a lot of people crazy with that k, but you know, that's what the exponential natural log is. All right, so let's go to the next question. All right, so for question D, what we've got is we've got a tangent to the quadratic, blah, blah, blah. Find the value of k, determine where the quadratic crosses the y-axis. Okay. So what we need to do is we probably just need to substitute this equation into the other one. So I'm going to take the first equation here. We've got 2y is equal to 2x plus 29. And I'm going to rewrite this as y is equal to 2x plus 29 divided by 2. Then I'm going to get 2x over 2 plus 29 over 2, which means I'm going to get this straight line as y is equal to x plus 14.5. Now the reason I did this is because I want to actually substitute the equation of y into that quadratic equation, so I only have x's to deal with, and then I know that discriminant has to equal to 0 because I'm looking for one crossing over once. So with that in mind, I've got x squared minus 2k. The y is equal to x plus 14.5 plus 32k is equal to 0. So expanding the brackets, so I've got to expand this and this part and this part. So I'm going to get x squared minus 2kx plus 29k plus 32k is equal to 0. I think I just realized that should be minus 29k. There we go. So I've got to end up with x squared minus 2kx plus 3k is equal to 0. So the next part is, remember that it's only cutting, it's a tangent to the quadratic, right? So if the quadratic is like this, if it's a tangent, then b squared minus 4ac is equal to 0. So I'm going to put down b squared minus 4ac is equal to 0, which means I now need to figure out what my a value is. A value is right there. My b value happens to be this entire thing there, negative 2k. And finally, my c value is going to be plus 3k. So with that in mind, negative 2k squared minus 4 times 1 times c, which happens to be 3k, is equal to 0. So I'm going to get 4k squared minus 12k is equal to 0. I could factorize this with taking 4k out, which means I'm going to get k minus 3 is equal to 0. Therefore, 4k is equal to 0, or k minus 3 is equal to 0. So I'm going to get k is equal to 0, or k is equal to 3. Now I'm going to figure out which of these values I got to go with, because there's k is equal to 0 and k equals to 3. The problem is, if I put k is equal to 0 into the quadratic, so have a look here. If k equals to 0, then the quadratic will become x squared minus, well, there's a k there, so that'll become 0, because 2 times 0 times y is just 0, plus 32 times 0 is 0, is equal to 0. So what I'm going to end up with is x squared is equal to 0. So therefore, k can't actually equal to 0. So we're going to have to say, therefore, k is equal to 3. Now the question does ask us, where does the quadratic actually cross the y-axis? So we've got to actually substitute k as 3 into the quadratic, which means we're going to get x squared minus 2 times 3y plus 32 times 3 is equal to 0. So we've got x squared minus 6y plus 96 is equal to 0. Rearranging this, I'm going to get x squared plus 96 is equal to 6y. And then I can say that y is equal to x squared plus 96 divided by 6. Just going to rewrite it this way. X squared over 6 plus 96 over 6. So y is equal to x squared over 6 plus 96 over 6 is 16. So we've pretty much figured out where it crosses the y-axis. So we can actually say crosses the y-axis at 0, 16. Well, you could have just said 16, that's fine. Whew, that went dark completely. All right, so with that in mind, we've got a schedule here, so let's just kind of mark this. So grades wise, K correct, both K and Y intercept correct gets you a double excellence. So basically that's 8 points there for this, but setting discriminant equals to 0 gets you a merit. So that would be somewhere around here. And then achieved is first step in solving simultaneous equations or y-intercept correct. Jeez, where would I put the achieved? First step in solving simultaneous equations correct. So I probably would say somewhere around here is where you're looking at an achieved. You're trying to give an equation in one variable only. That could be achieved. And that is question 1. Let's go to the next question. All right, so for question 2, what we've got is we've got a standard log question here. But what we're going to do is go into the formula sheet and just remember this part here. If you ever get stuck in the log questions, grab the formula sheet and have a look at this part and things should kind of make sense. So I would actually take a highlighter and just kind of like highlight the B so you know where it goes and highlight the Y so you know where it goes. But anyway, let's go back to this question here. So what we've got here is basically 2 to the power of 4 is equal to 3m plus 1. That's all it means. So 2 to the power of 4 is equal to 16, and we got 16 is equal to 3m plus 1. Rearranging this, actually I'm just going to rearrange it like this first. 3m plus 1 equals to 16. Then 3m is equal to 16, take away 1. And what I've got is 3m is equal to 15 and m is equal to 15 divided by 3, which gives us m is equal to 5. Now grades wise for this particular question, m equals to 5, you need m equals to 5 to get an achieved, and that's the first part of this done. Now the second part of this question is what we've got is solve this following equation, right? So I guess the first thing we want to try and do is get rid of that 3 in front there. So we're going to rewrite this as log x 64 is equal to 6 divided by 3. And then we've got log x 64 is equal to 2. And then from here, what we can actually say is that x squared is equal to 64. And now what we have is x is equal to square root of 64, which is actually equal to plus or minus 8. But this part is important, right? So you kind of need to mention that x can't be negative because partially you can't actually have base because base can't be negative. So we just need to make sure we write that down. And this is important because what that means is, like, I'm talking about this base right here. So that number can't actually be a negative number. It has to be a positive number. And so because of that, this question with the reasoning, you actually end up getting actually a merit for the reasoning. Now, if you don't write any reasoning and you just write the answer by itself, like x equals to 8 or negative 8, then you're actually going to end up with an achieved. Sorry, I just realized something. I should have actually written down that therefore x is equal to positive 8. Awesome. All right, so next question here. Oh, I gotta love these questions, right? Gotta love these questions. All right, so with this question, what we've got is find an expression for p. As you can see, you're working with 5, 25, and 125. Now we know that 5 squared is 25, so 5 cubed, just let's check it. There we go, that's 125. So I'm going to write this entire thing in base 5. So that means I'm going to have 5 to the power of 7x plus 6 divided by 5 squared to the power of negative x equals 5 to the power of 3 to the power of p. So with that in mind, what I can then do is I could actually just go, hang on, let's just do this. What I want to do is I want to get rid of those brackets there. To do that, I can write this as 5 to the power of 7x plus 6 divided by 5 to the power of 2 times negative x is negative 2x equals 5 to the power of 3p. Now the next thing is whenever I do what do you call it? You've got to subtract those powers, right? Because the bases are the same. So I'm going to write this as 5 to the power of 7x plus 6 minus negative 2x. Because remember, you're actually subtracting the power when the power is at the denominator. You've got to subtract the power. That means we're going to get 5, 7x plus 6, minus and minus becomes plus, that's 2x. Sorry, I forgot 5 to the power of 3p here. Also have 5 to the power of 3p here. So simplifying this, I've got 5 to the power of 9x plus 6 equals 5 to the power of 3p. Now, because my two bases are the same, I could actually just put the two powers equal to each other, which means I'm going to get 9x plus 6 is equal to 3p. So with that in mind, I'm just going to flip this around. So 3p is equal to 9x plus 6. And then p is equal to 9x plus 6 divided by 3. Let's put that in red. And from here, separate the brackets, which means I'm going to get p is equal to 9x over 3 plus 6 over 3. P is equal to 3x plus 2. So grades wise, what we're looking at is getting calculator move. Yep. So getting the 3x plus 2, simplification is not required. As long as you put p equals to x on the other side, you can actually end up getting a merit for this question. As for the achieved, conversion to either 5 to the power of 3p or 5. Wow, really? That gets you an achieved? It's incredible. So basically doing this or this will get you an achieved. That is possibly one of the craziest free achieveds I've seen in a level 2 paper in a very long time. It is what it is. All right, so let's go to the next question. Yeah, by the way, that was just a merit question. Okay, so with the next question, what we've got here. Oof, good Lord, how do we do this question? Now for this question, you actually have to go back to the log rules again, all right? So let's gonna try this again. Right screen, is this gonna work? Yes, it is. So I want to be looking at this particular rule here. I'm just gonna copy it down to the side here so that when we are actually using it, you will actually see how I'm going to go about solving this. So y is equal to bx, then x is equal to log base y. Okay, so let's go back to the main one. So I've copied that equation down here because the reason is I am going to use the x equals log by to figure out what this ugly looking thing in the middle is. So the way I'm going to do it is I'm going to take x equals log base y. Now if I do that, I'm going to take the first example, right? So I can write this as x equals log base. Now instead of y, I've got 1 over b3. That's it. I've done that part. Now if I look at this whole equation, I can actually rearrange this as y equals to bx, because if I match it right, so see, this is the y part here, this is the base, and then this is the x by itself. And remember that x equals to log base y is the same thing as saying y is equal to b to the power of x. So if I look at the yellow part, the y is actually 1 over b to the power of 3, which equals b to the power of x, because I already have that b, right? I mean, like, look at it. The b is b, the x is the blue part. It's done. So what I can do next is I can actually rewrite 1 over b to the power of 3 as b to the power of negative 3 equals b to the power of x. So from here, what I've done is I could say that x is equal to minus 3. So this entire equation here, this entire equation is equal to negative 3, because that's pretty much what we've done with the log rules. So if we look at the next one, we've actually got, I'm going to write down x equals to log b, y again. But in this one, I've got log b root b. So again, this is the y, this is the base, and this is x. So I can rewrite this as y equals to bx, where this is the y, this is the base, and this is x. So I can say y is equal to square root of b equals bx. Now square root of b is just b to the power of half. And then I can say, which is equal to bx. So the x for, in this case, is actually half. And that's for this part here. I've actually shown that x is equal to half. And sorry, I kind of rubbed this out, but this part here is actually equal to -3. So if I want to find the value of it, I'm going to get 6 plus whatever is in the blue box plus whatever is the green box, which means I've got 6. That becomes plus -3 plus a half, which means the answer that I'm going to get is 3.5. I'm hoping that I'm on the right track here. Yep. 3.5 is the final answer. Now, grades wise, this is one of those really weird questions, because it's like you're sitting there going, God, this is quite straightforward. I mean, all you're doing is just kind of rearranging and finding what the value is. But of course, in an exam, you've not seen this type of question and you go, well, where did this question come from? But that's the nature of these types of questions, right? So they always give you what you need in the formula sheet. And it's always stuff that you've done. It's just like in the moment you go, oh, I haven't actually learned this. But in reality, the more you practice these types of questions, the more you go, oh yeah, there must be a way here, right? And I look at it in hindsight now. This is actually quite a nice question. But anyway, grades wise, correct value, even if the candidate goes directly to the numerical values. Wow. So even if you go straight forward to -3 plus half, just you give the final answer as 3.5, you're going to get an excellence grade for that. That is just insane. Rewriting both long terms, bringing down the power. Jeez, I don't know. Like trying to decode the answer schedule here, because I'm not really sure what you're going to get merit for. Rewriting both log terms, bringing down the power. Bringing down the power. I don't know. I'm guessing, is it somewhere here? I'm sorry, folks. I don't know which one it is. Combine logs into one log, example base. Oh, okay. So some people, what they do is they actually multiply these two logs, I think. Is that what they're doing? B to the power of 3, b negative half. What are you going to get? Half. Oh, so it's like combining two logs together. So they would have actually multiplied the two logs. But yeah, again, achieved grade for that. So it's just one of the things they give achieved for. Like, let's have a look at this. Combining logs into one log term. So that's like when you do these two things combined together, potentially you'd get log b minus 2.5. Yeah, no. So that's what an achieved is worth. But anyway, look, that's covering this question here. Let's go to the next question. This is one of my favorite questions. And I think the people that, when they see this question, they go, yes, we got an amazingly easy excellence question. And some of you will sit there going, I've got no idea how to do this. And this is one of those frustrating questions. But anyway, look, I will literally show this to you in like 2 steps. And then you'd be like, this is the most easiest question you're going to get. So what we're going to do is we are going to replace. That's right. We're going to replace. I'm going to put down p is equal to 4 to the power of x. When we do this, we're going to get p minus 10 over p equals to 3. Now I want to get rid of the p from the denominator. So what I'm going to do is I'm going to multiply every term by p. And so when I do this, I'm going to get p squared minus 10 equals 3p. Rearranging this, I'm going to get p squared minus 3p minus 10 is equal to 0. We've got a straightforward quadratic equation to do. So this is going to be p minus 5, p plus 2 equals to 0. Therefore, we can say that p minus 5 is equal to 0, p plus 2 equals to 0, p is equal to positive 5, or p is equal to minus 2. Now, the thing is, we're trying to figure out what x is. So we've got to put p is equal to 4x. So 4 to the power of x is equal to 5, or 4 to the power of x is equal to minus 2. Now here, what we're going to say is negative values, so not possible or not valid. Therefore, 4 to the power of x is equal to 5. Then we're going to take log of both sides. So we've got log of 4x equals log of 5. Bring the x to the front, which means we're going to get x log 4 equals log 5. And then x is equal to log 5 divided by log 4. So put that in the calculator. Where is my calculator? There it is. All right, so we've got log 5 divided by log 4. And you're going to get 1.16. Now let's say instead of log you use ln. You're still going to get the same answer. Ln of 5 divided by ln of 4. That's still the same answer. So x is equal to 1.16. So grades wise, we are looking at a lovely excellence grade for this particular question, 1.16. Solved for you, it's u is equal to that. It's probably like, I'll probably say merit solved for you. So you, see, I'm not sure. I probably would put a merit here, but I think in this, my case, I've actually used, instead of u, I used the letter P. Doesn't matter, you can still use the letter P. As for achieved, obtains 4 to the power of 2x or 16x or 3g4x. Geez, 3g4x. I've not seen that. Let's have a look at the schedule here. Trying to understand which part of it you're going to get achieved. So 4 to the power of 2x, we didn't do that method. 16x, we didn't do that method either. Or 4x squared, didn't do that method. Or 3g4x. 3g4x. Yeah, not sure where that is. In terms of our case, I would probably say that for achieved, I'll probably say getting to the quadratic would probably get you an achieved, even if you kind of incorrected, but that's my, I need to put this is my achieved thing, but of course the answer schedule is just saying different things here. But anyway, folks, that is question 2. Let's go to the next one. All right, so for question 3, what we've got is our first question, which is solve the following equation. So we're just going to rewrite this as 5x squared plus 13x minus 6 is equal to 0. Now, you could use the quadratic formula and trying to work this out in the long method. That's absolutely fine. But of course, I'm hoping that you have a graphics calculator at this point, because you can just throw that in there under polynomial, 2 degrees. We've got 5, 13, and minus 6. When we do this, we're going to get x is equal to 0.4 and x is equal to minus 3. And with that in mind, looking at the answer schedule, they're just looking for the 2 answers. So that's going to get you an achieved. Now, if you don't have a graphics calculator, yeah, so you've got to use the quadratic formula for that one. So that's the one where you kind of go x equals to minus b plus or minus b squared minus 4ac over 2c. Now again, if you do forget the quadratic formula, remember the quadratic formula is actually in your formula sheet, so you can actually just pick it up from there and work the answer for this particular question. All right, so let's go to the question part 2. Here we go. So this is kind of reminiscent of a question that we did earlier. So we're going to have to factorize the numerator, factorize then the denominator. So, but unfortunately with this denominator, we've actually got 2 kind of factors, so it's a bit of a guessing game. But let's do the bottom one first. So 9x squared minus 16, that's just going to be 3x minus 4 or 3x plus 4. And like I said, my cheating method does not work in this case because there's actually 2 factors in the denominator. Well, 2 brackets. But what we can do is we can actually go to the calculator and kind of get those two solutions and work backwards. So we're going to go 3 minus 10 and 8. And when we do this, we're actually going to end up with a couple of things here. So the first thing is that our first solution is x is equal to 2. Now if x equals to 2, we're going to rearrange this. X minus 2 is equal to 0. So that's my first factor. And then my second factor, if I go down, the second solution, sorry, that's actually 4 over 3. So if that's 4 over 3, I'm cross-multiply the 3 first. I'm going to get 3x is equal to 4. Rearrange it. 3x minus 4 is equal to 0. So I can go back here. 3x minus 4. And as you can see, one of those factors, 3x minus 4 cancels out. And I'm left over with x minus 2 and 3x plus 4. Unfortunately, while this question used to be a merit a few years ago, this is now worth an achieved. There you go. How times have changed. I think this question is probably a merit in level 1 now. Anyway, that's level 1 MCAT. Oh, never going to see that one again. Okay, so for question B, what we've got is when is this quadratic for what values of p does not cross the x-axis? If it doesn't cross the x-axis, then the discriminant has to equal to negative numbers. So we're going to put that as b squared minus 4ac has to be less than 0. So with that in mind, we've got a is equal to 2, b is equal to 8, and c is equal to p. So we've got 8 squared minus 4 times a, which is that, times p has to be less than 0. So with that in mind, what we've got is we've got 64 minus 8p has to be less than 0. So we've got negative 8p is less than negative 64. And then we've got p has to be negative 64. And remember this from level 1. If you're dividing it by a negative number, you actually have to switch the sign. So what we're going to end up with is p is actually greater than positive 8. So with this in mind, grades wise, correct answer is going to be, oh no, correct answer is actually merit, sorry. That's actually merit. Setting up inequality line 3, 1, 2, 3, that's going to be an achieved up to here. You could write down p equals to 8 or p less than 8 if you make a mistake. So if you actually wrote like this, p less than 8, you could also end up with an achieved. All right, so let's go to the next question. So the next question, what we've got is we've actually got to work out what the k value is. And a couple of ways of doing this. As I mentioned, there's a couple of ways of doing this. Sorry, I kind of had to pause and go which method I'm going to go with. So the method I'm going to go with, this one here. What I want to do is on the right hand side, I know I'm going to get x minus 3 and x plus 2. Now I'm going to look at the denominator of the left hand side. That is something I can factorize. X squared plus 7x plus 10. I can factorize it as x plus 5 and x plus 2. Now if you think about it, on the denominator of the right hand side is an x plus 2, which means I've actually got an x plus 2 on the left hand side, which also means that numerator, you know how I've got a k at the top there, but I do know the x plus 5 is actually going to get cancelled out. So you almost got to write it like this, right? Because it's like, you know that this x plus 5 is going to get cancelled out. So that's why one of those brackets in the numerator has to be x plus 5. If that happens, then what's remaining is x minus 3, which is what's left over on the left hand side and the right hand side. Hopefully I kind of made sense what I try to do there, because I can't actually factorize x squared plus 2x plus k, but what I do know is that somehow I need to balance the right hand side and the left hand side. So with that in mind, I can now say the numerator is equal to x plus 5 times x minus 3. And if I expand the brackets, so if I do, whichever method that you're comfortable with, I'm going to get x squared plus 5x minus 3x minus 15. And of course, this simplifies to x squared plus 2x minus 15. And if you look at the quadratic there, I've got x squared plus 2x plus k. Therefore, I can say that k is equal to negative 15. Grades-wise, getting the k equals to negative 15 is worth a merit. And for achieved, making progress towards solution by eliminating denominators or equivalents. So this is what I did here, which is the eliminating denominators, and that might get you an achieved there. Okay, so with that in mind, we go to the next question. All right, folks, so with this particular question, what we've got here is we've got a boat, and then we've got this little canal, the cross section of the canal that we need to figure out. What else? The boat must maintain a constant depth below the water at 1 meter in order to float. All right, so what we're going to have to do is, the first step is find out the parabola, the cross-section parabola curve of the canal first. Now to do that, what I'm going to do is the classic, I'm just going to run the y-axis right through the middle and the x-axis through there. All right, if that's the case, then I know that this quadratic is going to have a formula of ax squared plus c, because I mean, I could use the vertex form, but it's because the parabola is just moving up or down. I'm straight away going to use ax squared plus c. Now I know the plus c, it's cutting it at 3, like this part right here is minus 3. So I'm actually going to write this down straight away as y is equal to ax squared minus 3. Now I need to figure out what the value of a is. I do know, and I'm sorry, I'm going to rub this part out because it's a bit messy, because you can't see the actual numbers there. But maybe I'll put it in like that. No, that's a terrible color. Hang on, let's try this. So hopefully you can see my x and y axis there. Now this point right here, this point B, is going to be at 1.25 and 0. So that's at 1.25 meters, because that's 2.5 meters is the width of the canal itself. So 1.250 is one of the points I could use to figure out the a value. So I'm going to use that, 1.25 and 0. So I'm going to get 0 equals a times 1.25 squared minus 3. Rearranging this, I am going to get 3 is equal to a times 1.25 squared is 1.5 something. Let's have a look. Menu 1, 1.25 squared equals 1.5625. So then I can say that a is equal to 3 divided by 1.5625, and whatever that value is. 3 divided by answer, that is 1.92. So with that in mind, I've got the equation of the parabola of the canal, y equals to a, which is 1.92x squared minus 3. Now, what I'm going to do now is I'm actually going to figure out like where the canal at 1.1 meters, right? Like I need to do 1.1 meters because that's the bottom part of the boat. But if, like, what I'm trying to figure out is this point right here. Because I know the x value is going to be 1.1 because that's the width of the bottom of the boat. And I want to figure out what the where the water is going to be, right? Because I want to actually try and see if that ends up being at -1, then the boat is fine to float. But if it's less than -1, then it's not. If it's above -1, then it's all good as well. So because what I want to know is what is the water depth at 1.1. That's what I'm trying to figure out. So with that in mind, I've got y is equal to 1.92 times 1.1 squared minus 3. And so when I do that, let's actually go to the calculator. So we've got 1.92 multiplied by 1.1 squared minus 3. And that's going to give me a y value of negative 0.6768 meters. And like, let me just blow this up for you, right? So what it means is that if I take the river like this point here is 1.25 and 0. But if I take somewhere around here, so basically from here to here is 1.1, so this point is going to be 1.1 and negative 0.6768. Now, if I was to think about it like the boat is going to fit there like that. All right, because that's the boat's fitting there with the bottom of it being 2.2 meters, the bottom of the boat. But as you can see, below the water level is actually only 0.6768 meters. And it's negative because it's below from the top of the surface, right? So with that in mind, we can actually say boat will not float. And you could actually write a little statement saying that it is short by 1 minus that. So I'm just going to go 1 plus that actually to give me the so it's actually short by 0.3232 meters. So grades wise, what are we looking at? Depth of canal at appropriate width, or width of canal at moment depth calculated. Yeah, statement that the boat will not floor. So you kind of need the statement and the measurement to get an excellence grade. Coefficient of x squared found is a merit. Wow. Just finding that 1.92 is a merit. General equation fitting the context form in any correct format. Oh wow, okay, so basically that right there is going to get you an achieved. General equation fitting the context formed in any correct form. Yeah, so that second line is probably going to get you an achieved. Finding the A is going to get you a merit. Finding the final answer is going to get you an excellence. I'm surprised by how lenient they are with this particular question, but it is what it is. All right, so let's go to the next question. All right, folks, so for this particular question, what we've got here is write an expression for h in terms of the radius r. So what we've got a box, no lid, 5 sides. So that means, what is it? The open box has been designed, blah, blah, blah. Surface area is equal to the surface area of the candle. All right. So what we're going to do is surface area of box is equal to surface area of candle. Now with the surface area of the box, we don't actually have a top, so we've got 4 sides and 1 bottom. So 4 sides and a bottom, and then we've got the surface area of candle itself. Now surface area of box, couple of things to consider. All right, so the first thing is this: we've got the distance from here to here. Because r is actually from the center of the cylinder to the edge, we can say that this is going to be 2r, and then from here to here is also going to be 2r. So if you look at the base of that surface area of the box, it's going to be a square. So I'm going to put that as a square like this, which is going to be 2r and 2r. Plus we've got 4 sides, and for the sides we have h and as the height and 2r, so we got 4 lots of that, equals the surface area of the candle, which happens to be 2 pi r squared plus 2 pi rh. So now what we've got is we've got to work out the area of the red square, which is the base, the bottom of the box, right? So we've got 2r times 2r, which is 4r squared, plus we've got 4 multiplied by h times 2r, and all of this is equal to 2 pi r squared plus 2 pi h. So expanding the brackets. So when we expand this brackets, we've got 4 times 2 is 8. 8 times hr, well, that's just going to be 8rh equals 2 pi r squared plus 2 pi rh. Now my main mission is to bring h together and then get rid of all the r's to the other side. So to do that, we're going to write down 8rh, and I'm going to bring this fella here first, which is 2 pi r h is equal to 2 pi r squared, and then I'm going to bring in the 4r squared to the other side, which becomes minus 4r squared. Next step is taking the h as a common factor, so I'm going to get 8r minus 2 pi r is equal to 2 pi r squared. I might actually just take 2r squared as a common factor, which means I'm going to get pi minus 2. Is it? Yes, pi minus 2. That's looking right. So then I'm going to get h is equal to 2r squared over pi minus 2. And that whole thing is now divided by the 8r minus 2 pi r. Now theoretically, I could actually leave the answer like this because, I mean, I have actually kind of got the right expression here. H is in terms of r. But looking at the answer schedule, it actually gives you only 1 excellence for correct expression, but not simplified. So you've got to actually simplify it to get the double excellence grade, which means we need to do a little bit more work here. So we've got h is equal to 2r squared pi minus 2. And when I've factorized the denominator, I've got, what is it, 2r is a common factor, which means I'm going to get 4 minus pi. And then, of course, I can cancel out the 2's, cancel out the r, and I'm going to get just r1. So h is equal to r pi minus 2 divided by 4 minus pi. So grades wise, correct expression and simplified is actually going to get you E8, which is the 8 points, rather than just the 7. Had you done it only up to here, that would have been an E7. This would be an E8. Merit wise, gives R correctly in terms. Okay, I'm just going to show you folks the answer schedule because it's like too hard to understand. All right, as you can see, setting up initial equation gets you a merit. Gives R correctly in terms of H. Box is incorrect. So, okay, we've got something else that's popping up here, and indecipherable. Lovely. So where would I give this a merit? Where would I give this a merit? Set up initial equation. There we go. I think that's a merit right there. So I'd probably say somewhere here. That's the initial equation that could actually get you a merit. And that's a wrap for question 3 there, folks. Now, as I said last year when I actually did a speed run of this question, and I do have to apologize for those people that were still doing the exams during that time, and it was kind of insensitive of me to do a speed run, because I know people started getting stressed out more than anything else. But anyway, in saying that, at the end of the day, this paper wasn't actually too bad at all. Fairly straightforward, the achieved questions, straightforward for the merit questions, and a couple of really easy excellence questions in this paper. So yeah, I was actually not too, what do I say? Like, I know a couple of years ago, some of those papers were like really tearing my hair apart, but this one was fairly straightforward. So folks, if you have any questions or anything like that, just drop it in the comments below. I will try and get to it, and any comments as well, throw it in there.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material, and as always, thank you for watching.